Hello everyone, this is the second video on the concept of real numbers. So in this video I will tell you how to find the HCF of two numbers using Euclid's division algorithm. But before that I will give you a brief recapitulation of the concept which you have studied in the first video. In the first video you have learned about the real numbers. So real numbers are those numbers that can be represented on number line. So your real number includes both rational as well as the irrational numbers, because you know very well that you can represent both rational and the irrational number on the number line. Next we have discussed about the Euclid's division lemma. So lemma is basically a proven statement which is used to prove the other statement. Just like we have the theorems that we use to prove the other theorems, same way we have the lemma, a proven statement that is used to prove the other statements. So what Euclid's division lemma says, it says any positive integer a can be represented in the form a equals to bq plus r, where remainder r is less than or greater or equals to 0 but less than your b. So this is not basically anything special kind. It is just like we having our dividend equals to divisor into quotient plus remainder. Means when we are dividing our a with b, we are getting some quotient q and the remainder r. And we know very well when we check our division, so we get dividend equals to divisor into quotient plus the remainder. So same thing we get from the Euclid's division lemma, a is equals to bq plus r. Next thing is the finding HCF using your Euclid's division algorithm. So to find the HCF using Euclid's division algorithm, we'll take a simple example. We have to find the HCF of 225 and 425. So what your algorithm says, the larger number is a and the smaller number is b. So in this case our a is 425 and our b is 225. Now what we have to do, we have to divide our 425 with 225. The division should be in the one step only. It means you have to completely divide the number in a one single step. So 225 1 is 225 and 225 2 is 450. So 1 times when you go, you will get 225. Remainder 0, 0 and the 2. So what you will write? You will write using Euclid's division algorithm. This is the first step. You are expressing your a in the form of bq plus r. So a here is 425. So we can write 425 as 225, that is our dividend, into 1, that is the quotient, plus 200, that is the remainder. Means we are getting here a equals to bq plus r. Now in this case, since remainder is not 0, we have to go for the next step, step number 2. Now what we will do, we will divide our 225 with your 200. So 200 1 is 200. You will get how much remainder? 25. So in the step 2, now you will write 225 as 200 into 1, that is your quotient, plus 25, that is the remainder. Again remainder is not 0, so we have to go for the next step, step number 3. Now we can write 200 as, so 25 and the 200, so 25 is 200 and remainder is 0. So 200 can be written as 25 into 8 plus remainder is 0. So in this step, when you get the remainder as 0, the divisor of that step is your HCF. It means in this case your HCF is how much? 25. So let us take one more example. Let us find the HCF of 30 and 200. So again, the greater number is A and the smaller number is B. So in this case, now our A is 200 and our B is how much? 30. So first of all, we have to divide 200 by 30. So in the one single step, we have to divide this complete value. So 30, I think 6 times is 180 and remainder is 20. So you have to write again using Euclid's division algorithm. Now the step 1. So you can write 200 as 30, that is the quotient. So it is the divisor into 6 plus your remainder is 20. Since remainder is not 0, so what we will do? We will divide 30 by the 20. So 20 ones are 20 and the remainder is 10. So next you will write step 2. So what you will write? You will write 30 as 20 into 1 plus remainder is 10. Again remainder is not 0, so we have to go for the third step. Now 20 will be divided by 10. So 10 to the 20, remainder is 0. So step number 3. So 20 now you can write as 10 to the 20 plus remainder is 0. So now you are getting remainder 0. So your HCF is how much? 10. And you can get many steps. It is possible that you can get one step also, or you can get more than one step also. Like if you find the HCF of 50 and 10. So in this case, you will get the answer in just one single step, because when you divide your 50 with the 10 5s are 50, remainder is 0. So using Euclid's division algorithm, only in the single step you will get your answer. 50 you can write as 10 5s are 50 plus remainder is 0. So your HCF in this case is how much? That is your 10. So steps depends on the two numbers, that how many steps are there to solve the numbers. So I hope now you are able to find the solution for this one. So if you have any issues, then you can ask. Thank you.